Zero and negative exponents. How do we solve zero and negative exponents? Let's have here an example. Positive 4 and a raised to negative 5. We will first discuss negative exponents. Okay, so if there is a base with a negative exponent, all you have to do, if the base is on the numerator, all you have to do is transfer the base to the denominator and make the exponent positive. If there is a numerical coefficient or other terms that have positive exponents, they remain on their place. Just like this positive 4, its exponent is positive 1, it will not be touched. Okay, so let's have the solution for this. 4 will remain on the numerator, and then our base now will be on the denominator, and instead of negative 5, the exponent now will become positive 5. 4a raised to negative 5 is equal to 4 all over a raised to positive 5. Let's have another example. We have here 2 all over b raised to negative 3. In this example, the base with the negative exponent is on the denominator. So what we need to do is that we will just do the reverse. From the denominator, we will put it on the numerator and making the exponent positive. 2 will remain on its place, so we have here 2, and then from the denominator, our b now will be on the numerator, and then our exponent from negative, it will become positive 3. 2 all over b raised to negative 3 is equal to 2 and b with exponent raised to positive 3. Let us now discuss zero exponents. Let's have here an example. A raised to 0. Now, the rule for zero exponent is that any term, any quantity raised to 0, the answer is always 1. So for a raised to 0, the answer is 1. How about if we have here a binomial, the quantity of b minus 2 raised to 0? Again, even if it is a binomial, as long as it is enclosed in a parenthesis and the parenthesis is raised to 0, this is still equal to 1. But what if we have here x plus y all over x minus y, but the whole quantity is raised to 0? Again, this is still equal to 1. So take note, any number, any variable, or any quantity raised to 0, the answer is always 1. Let's now have a sample problem. We have here x raised to 0, a multiplied by b raised to negative 3 multiplied by c. Okay. X raised to 0, any number, any quantity raised to 0, the answer is 1. This will be 1. A, it has a positive exponent which is positive 1. It will remain here as a. B raised to negative 3. Okay, it has a negative exponent. B raised to negative 3. What will happen to the base with a negative exponent? To make this positive, we are going to put this on the denominator, and then our exponent now from negative, it will now become positive, so positive 3. And then C, it has a positive exponent, it will remain here on the numerator. And our answer now will be A multiplied by C all over B raised to 3. Let's have another example. The quantity of x plus y raised to negative 2 multiplied by x minus y raised to positive 2. Since this is taken as a whole quantity, so this will be our base. So again, this is a negative exponent. What will happen to the base with an exponent that is negative? It will be put on the denominator. So since this is taken as a whole, this will now be our base. It will be the quantity x plus y. And from the negative exponent, the exponent now will become positive, and that is positive 2. What will remain on the numerator now will be the quantity of x minus y raised to the power of 2. And this is our answer for the second problem. Next, we have here a raised to negative 3 multiplied by b raised to positive 2, c raised to negative 5, all over x raised to negative 2 and y raised to negative 4. So we have here bases with several negative exponents. We will transfer them. A raised to negative 3 from the numerator, that will now be on the denominator. Okay. So again, from the numerator, a now will be on the denominator. The exponent now will become negative. It will now become positive 3. Okay. And then after a will be b. Since this is positive exponent, it will still be here on the numerator. And then we have c, which has a negative exponent. So just like a, c will be here on the denominator, and then the negative exponent will now become a positive exponent. Our x here has a negative exponent, so from the denominator it will go up. It will now be on the numerator, and the exponent now from negative, it will become positive. And how about for y? Y here has a negative exponent, so from the denominator it will now go up on the numerator, and from negative 4 the exponent now will become positive 4. So therefore our final answer here will be b squared x raised to the power of 2 y raised to the power of 4 all over a cubed and c raised to positive 5. We have here our next example. We have the quantity of mn raised to 0 all over the quantity of bc raised to 0. Any quantity raised to 0, the answer is 1. And again, any quantity raised to 0, the answer is 1. Therefore, our answer here is 1 divided by 1, that is 1. And we have here another example, 10 plus 2x all over the quantity of 5x squared plus 2xy minus 10, and the whole quantity is raised to 0. So for the numerator, this would still be 10 plus 2x, but for our denominator, since any quantity, any terms raised to 0, the answer is still 1. So 10 plus 2x divided by 1, our final answer here would be 10 plus 2x.